Alright guys, there are two things that we want to cover today. The first one is the capital budgeting techniques. I believe it's chapter 7 in the new book. And the second one, if we can, hopefully we'll have enough time, is the second portion of the stocks chapter. Okay, second and also first, because we didn't spend a whole lot of time on them, and I want to spend a little bit more time on that than we have last class. So remember, managers have to evaluate, financial managers have to evaluate different projects or products. And they need to decide whether the investments that they're thinking about or the projects that they're evaluating are worth it or not. And that decision is known as the capital budgeting decisions, all right? So whether they should go through with an investment or they should not go through with an investment, that's basically the capital budgeting decision of a firm. If you remember vaguely in chapter number 1, we looked at what are the different things that financial managers do, and one of them was, making capital budgeting decisions, whether or not, again, they should go through with the project or not. And in this chapter, we're going to learn a couple of techniques. All right, most of the techniques are, elaborated in the book and explained pretty well in the book, of all the or most of the techniques that managers use again to evaluate projects. So I have an example here. There are several examples in the book as well. But Apple CEO Steve Jobs was, instrumental in coming up with all these products that we use, most of us use, or many of us use, the iPad, the iPod, the MacBook Pro, and, so many other gadgets out there. But, we just look at the end result, all right, we have the product/projects over here. But, a lot of research and development funds went in, a lot of the Apple CEO and, all the members who were part of the project had to analyze, well, should we or should we not go on with the project? Are market participants going to embrace the products or not? Because again, if you think about 15 or 20 years ago, we didn't even think about all these products, and then boom, all of a sudden we are, we have to deal with these products, but do we like it or not? So there are many questions that they had to answer before launching the product. What we see is, well, these are the products, but we don't really see what went on before they again launched the product/project. So let's look at different techniques again, and the same goes for other kinds of products. If you just think of a designer handbag, we can say, well, this is the designer handbag, but again, a lot of research and development funds and a lot of there's a market analysis where a lot of things go on before the product or the projects are launched. Okay. So I have, were these projects worth it? Okay, so let's look at the different techniques, and you might have seen some of the techniques, you might not have seen some of the techniques, but we will talk in detail about each and every, or most of the techniques that the book talks about, that managers use again to evaluate products/projects. Okay, the first one is the net present value criteria. All right, so let's look at the equation for the net present value, and let's try to think about what does this equation really mean to us. Anybody, what does this equation really mean to us? The net present value criteria. So we have the C0 over there, we have a bunch of C's, and then we have the R in the denominator. Can anybody tell me, explain to me, what is the net present value criteria all about? What are managers doing when they look at that equation? Any ideas?
They're trying to see if it's worth it to invest in a long-term project based on the present value of what they think that the future cash flows are going to be.
Okay,
so what they're doing is just trying to bring them
Okay, very good. So, very good. So they're doing what's known as the cost-benefit analysis. In this equation, we have a C0, remember. The C0 is the estimated initial cost of the project. What is the cost of the project? Projects cost a certain amount, millions of dollars, hundreds of thousands, whatever it is. C0 is the cost of the project, and as your peer just said, C1, C2, C3, C4, CT are the future expected cash flows that the product is expected to generate throughout its lifetime. Remember, in marketing, you must have seen the product life cycle. You have the product, it is launched, and then it goes through a growth phase, and then it's saturation, and then finally decline. So, that is again estimate. So a cost-benefit analysis, meaning, evaluating, well, is the cost more than the present value of the future expected benefits or future expected cash flows, or is it less than, the present value of all the future expected cash flows that, again, the project is expected to generate throughout its lifetime. So cost-benefit analysis, again, meaning that we are comparing, or managers compare, what is going to be the estimated cost versus what is going to be the future expected benefits, or present value, future expected benefits. So the NPV formula boils down to, well, we will accept the project, obviously, if the cost is less than the present value of the future expected benefits, right? Conversely, if the cost is more, we are going to reject the project or product, okay? So in other words, the NPV criteria tells us that, well, accept any project when NPV is greater than 0 and reject any project when NPV is less than 0. So again, NPV greater than 0 would imply what? Well, it would imply simply that the cost, all right, let's say the cost is $2 million is less than, right, less than present value of all the future expected benefits, which is, let's say, $3.5 million, right? That would imply that NPV is a positive number, right? NPV would be a negative number if the cost, let's say, is $2 million, but the present value of all the future expected cash flows is, let's say, $1.5 million or $1.75 million, less than $2 million. To use formula, you might have seen this formula somewhere else, you might not have. And we have looked at the discounted cash flow valuation chapter, and we have done problems with that. This is simply a DCF model, but we have an addition to the equation, which is the C0, because we have the cost versus future expected benefits, and then we are evaluating whether we should go through with the project or not. It's a pretty easy to use model if you think about it, or it's a pretty easy to use criteria. Can you think about any problems with this model, or is this like a foolproof model? Any problems that you can think of just by looking at this formula? What is it? Is it foolproof? I mean, no model is foolproof. If the models were foolproof, we would never be in a recession. We would be in a perfect, quote unquote, perfect world out there. But any problems, Philip?
We're assuming the cash flow we're gonna be getting an estimation. It's not 100% assured that we're going to obtain those cash flows.
Okay. Right. To the point. So we don't know. Let's say again we're doing this analysis 10 years prior to, or 15 years prior to the launch of the project. We do not know with certainty what the cash flows are going to be. We can assume, well, these are the projected cash flows, but we don't know again with certainty what the cash flows are going to be. We have no idea. Again, these are estimates, but we don't know with certainty again what the cash flows are going to be. So again, I will look at some of the problems we can. So a problem for NPV will look something like this. It says, suppose you're asked to decide whether or not the company you're working for should launch a product, and expect the cash flows to be as follows. The cost is $10,000. Should you or should you not accept this product using the NPV rule? So we know that we can use our cash flow interface, all right, plug in all the numbers and evaluate again. Is NPV is a positive number, we say yes. If it's a negative number, we say no. Yes or no? But again, as Philip pointed out, the problems are with the cash flows. We're assuming in this simple example that in year 1, it's going to be $2,000. That's 100% probability it's going to be $2,000. That's what we're assuming. Year 2, again, 100% probable it's $2,000. Year 3, again, 100% probable that's $4,000, so on and so forth. So this is the basic model, but in reality, all right, and the book doesn't really talk in detail about this, managers do what's known as a scenario analysis, all right, a scenario analysis whereby they're going to assign probabilities to each and every cash flows. So it may look something like this. So let's say we have, in this case, 2,000, 2,000, 4,000, 4,000, and 5,000. So they might have, what's known as a binomial tree with different branches with probabilities assigned. Okay, so let's look at that. So let's say again in what's known as a sensitivity analysis or scenario analysis, the cash flows may not be one cash flow like that with 100% probability. It might be different cash flows with probabilities assigned. So for instance, we could have year 1 $2,000. And probability equal, let's say 50%, all right, or let's say, and this is going to be in a normal scenario. Year 2 or year 1, again, let's say $1,000, probability, let's say 25%, and recession. And let's say again, year 1, $3,500, probability 25%, super normal, or boom. So again, you could have, probability assigned to each cash flows and then stick it in the model and then, evaluate whether or not it's worth it or not. But this is going one step further. On the exam, I'm just going to give you the cash flows and, a bunch of numbers and say, well, should you or should you not based on the NPV criteria. But, just for you to think a little bit more, maybe in 625 you will do this. But, these numbers, again, we're assuming they're 100% probable, although they are, future expected cash flows. Nobody really knows what the cash flows are going to be. Is it going to be a recessionary environment? Is the environment going to be, or economy going to be normal? Or maybe it's a growth stage, or we're in a growth environment. What is it going to be? And the cash flows are going to be based on, that, right? If, again, the economy is in boom, everybody is happy, they have surplus income, and they can afford to buy this or that. But conversely, in a recessionary environment, people don't really invest or buy, gadgets that they probably don't need anyways. Okay, so just a thought. Just remember that. Although it is a good model, that's one thing. Scenario or sensitivity analysis. You could do, one of the things you can do is do that, assign probability to the cash flows, and then use the model. Okay. So question 1, question 2, question 3, if you can do one of them and make sure that you know how to do it. So again, anybody with question number 1, do you want me to go over it, or what is the answer for question number 1? So we have, as you know, the project cost $10,000 is going to be a negative number, CF 0. These are all the cash flows, I is 10%. Just tell me what the NPV is, so we know that, well, yes, you do know how to do the NPV, and we can move on to another criteria.
2312, does that sound good?
Right, I'm going to write it on the board. Michael M said it's 23, what is it?
2312.
012?
At least that's what I got.
012 approximately is the NPV for when?
2,312. Yeah.
Oh, okay. So 2312. Okay. And the answer should be yes again, right? Just know what the intuition is behind the NPV. Why is it, okay, yes, greater than 0, yes, less than 0, no. We're just doing, again, as one of your peers said, a cost-benefit analysis. Cost is more than future expected benefits. Obviously, the NPV is going to be a negative number. We say no. Cost is less, and we say yes. Okay, just remember that, but that's the implication for a positive number, negative number. Okay. All right, I'm assuming you can do example 2, because it's also a very, very easy example. I believe 10% you would say yes, and 30% you would say no, but you can try it out. The second technique we're going to talk about is the payback period technique. So just again, if you see this formula, you should be able to identify, well, this is the NPV formula. You should know the intuition behind it. You should know what C0, C1, C2, or if I have C0, CF1, CF2, you should know what those mean. You know what R is, or the opportunity cost of capital is, and of course you should know the decision rule, and that, well, the only major flaw is that we don't know the cash flows with certainty, but you can never know the cash flows with certainty. All right, the second one we're going to be looking at is called the payback period. Okay. So the payback period just asks you how long does it take in number of years? How long does it take for the project? Okay, so how long does it take for the project to recover or recuperate the initial cash flow of the project? Okay, so let's say the cost of the project is $10,000, so negative $10,000. How many years does it take to recover that $10,000, or negative $10,000? So the rule for the payback period is the following: accept a project if payback is less than a cutoff, all right, the cutoff, whatever the cutoff is. Do not accept it if the payback is greater than the cutoff period. So let's look at a couple of examples and see whether payback makes sense or not. And I've given you a handout. If you haven't picked up the handout, just raise your hand and I will give it to you. All right, a couple of you. I'll just give it to Wabe and she can just circulate it, since everybody at the back didn't get it. A lot of people in the back. But payback period again asks you, or the criteria asks you, how long does it take to recover the initial cost of the project? So let's look at these 3 projects that I made up, or I copied from a book, I guess. But we have project A, B, and C. And they have, the project cost 2,000, each of the project cost 2,000. But what is the payback for each project? Just look at them. You don't have to do any math or anything. Just look at the numbers and tell me what is the payback period for project A, project B, and project C.
2 years.
2 years.
All right, so how do we get 2 years? Of course, 1,000, 1,000, 1,000, 1,000, and then 2,000. What are some of the problems you can see? What can you see, or just by looking at the numbers, what are some of the problems with the payback period criteria? In your opinion, which one is the best project? If somebody just asked you, well, take a random guess, which one is the best project and why?
A.
All right, probably A, most probably A, because we have that $10,000 in year 3. So the payback period criteria is ranking all of the 3 projects equally, when we can, just by looking at the numbers, tell that, well, project A is much better than project B or project C. Okay, so the payback period criteria is kind of myopic or short-sighted, in the sense that it puts more weight on near-term cash flows and not less weight, or kind of ignores cash flows after the payback period. So A, B, and C, even if C03 was $1 million, all right, payback period criteria would say, be indifferent. Rank all of the projects equally. So of course, as you can see, you have to use your own judgment. Managers have to use their own judgment when they're evaluating projects, because they can't just be like, well, 10,000, million, 100,000, we don't care about it. All right, just for fun, let's calculate the NPVs and see what the is the NPV criteria guiding us in the right direction or not. So let's do the NPVs real quick. What is the NPV, right?
Yes.
Okay. Alright, what about project B and C? Negative numbers?
If I got B correctly, I got negative 264.46 cents.
Is there a consensus?
Yeah.
Alright, what about C?
Negative 347 and 11 cents.
Right. So we can rely on the NPV criteria, because again, it's guiding us in the right direction. It's telling us, well, A is definitely better than B and C because we have a positive NPV. But if you look at the payback criteria again, payback criteria is saying, well, a manager should be indifferent among all 3 projects, because payback for each of the 3 projects is 2 years. It doesn't make a difference. Another problem with the payback criteria is that it doesn't really take time value money into consideration. So it's saying, well, the $1,000 in C01 is the same. We're not, again, it's not discounting the cash flows. We're going to look at modification of the payback period criteria, which is known as the discounted payback period criteria, and we're going to work on that as well. Okay. But so just remember what the problems are. 1, short-sighted, ignores cash flows after the payback. Number 2, doesn't take time value money into consideration, but it's very easy to use. So even a 4th or 5th grader can solve a payback period problem and tell you, well, should you or should you not. So again, going back to, well, what is the payback criteria rule? Accept it if the payback period is less than a cutoff. Reject it if it is greater than a cutoff. Okay, so again, the cutoff period is also something that's pretty arbitrary. Nobody really knows what should be an optimal cutoff period. 3 years or 4 years or 5 years or 6 years, what is it? So in this example that we did, if the cutoff period was, let's say, 3 years, should we accept or not?
Yes.
Yes, we should, because it's paying back in 2 years. The cutoff is more than 2 years, so we should say yes. If it's, let's say the payback is 1 year or 1.5 years, we should say no, because again, that's what the criteria states. Right. All right, let's look at the handout that we have over here and try to solve a couple of payback period criteria. You know, that problem is structured in such a way that, you know, it was all the numbers matched up, and we had a whole number which was 2 years for each of the projects to recover the initial cash flow. What if that is not the case? All right, so what if, you know, we don't have really whole round numbers, but we have something left over? So let's look at this. I'm gonna open it up, and we will do a couple of problems where we're gonna solve for payback period when, again, the numbers are not very straightforward. All right, NPV handout. Let me see if I have this in Excel somewhere. All right, let's do something. I already gave you the handouts. Should already be part of the handout. Kind of paste over there. So let's say we have a situation like this. All right, so, and I'm going to highlight this yellow because this is what's given to you, okay? So we have a project A which costs $1,000, and then we have all these cash flows, all right? How do we find the payback period? So you see, well, we have 600 plus 300, 900, and it's not exactly 2 years, and it's not exactly 3 years either, right? So in a situation like this, let's say, you know, only this is given to you, what's in yellow highlights, what should we do? So we have 2 years, well, 2 years we're recovering $900, but not $1,000. But if we go to year 3, we're going over by $100. What to do then? So in a situation like this, where you can create another column and call it the cumulative column. All right, so we're going to say, well, this is the cumulative column. We have $600 that we recover in year 1, right? $900 in year 2, cumulatively, right? Yes or no?
Yeah.
All right, what do we have left over? $100. Yeah? So remember, the formula is this. I have the formula over here. Oh God, I can't even see anything in here. So I believe the formula is, I'm just going to read it. It's unpaid balance. I'm going to write it down over here. Unpaid balance divided by next free cash flow. Alright, so unpaid balance over here was $100. That means we have $100 left for us to recover the project, and then divided by the next free cash flow, which was $200. So the answer for this one, the payback period, is exactly 2.5 years. So again, if this is given to you, the one in yellow highlight, $600, $900, how much is left? All right, what is the unpaid balance now? Again, if we go to year 3, we're going over. We don't want to go to year 3. $100 left over, divided by the next cash flow, which is $200. So we have year 1, year 2, and 100 divided by 200 is 0.5, and therefore our payback period is 2 plus 0.5, or 2.5 years. All right, an extension of this model, because again, I just told you, well, you know, we're treating these cash flows as if they occur today, but actually they're occurring sometime in the future. This is in year 1, this is in year 2, year 3, year 4, year 5. But you know, we're treating these cash flows as if time value money doesn't really matter. We're treating these cash flows as if all these cash flows are occurring at time period 0 or now, but that's not true. So an extension of the payback period is what's known as a discounted payback period criteria, okay? So what do we do in the discounted payback period criteria method? We just need another column, all right? So we need another column where we discount the cash flows and then follow the same procedure. So instead of just adding the cash flows together and finding the cumulative sum of all the cash flows, we make another column where we discount the cash flows. We'll go over that. Discount the cash flows and then, you know, do whatever we're doing, have the cumulative column, and then, you know, find whatever our discounted payback period is all about. So here we are given again these two columns, And we have these three columns. Let's change the color for this and make it purple. Okay. I don't know how well you can see this, but in fact, we'll make it light purple. All right. So the discount rate is 17% here. Okay. So we have $6,000, and we want to find what the present value of that $6,000 is at the end of 1 year. How do we go about doing that? What do we do? Think about it. How do we come up with the discounted cash flow? So again, because the present values are not calculated in the simple payback period formula, right? We're again treating all the cash flows as if they're just occurring now. We have to discount the cash flows. So how do we discount them? So how are we getting 5128 at 17%? We can do one of two things, okay? So let's pull this up. We have everything over here. Have an idea. Should work. Is that better? You know what? Purple is not doing it. No? Yeah. Yeah, this is better. Right, so we have the 5128, and we want to figure out, well, how are we getting 5128 and 2922 and all that? And it's pretty simple actually, not difficult at all. And let's discount the cash flows. So cash flow 1 or year 1, we have $6,000, so we can either use the formula present value equal future value 1 plus I to the n. Right? All right, which is 6,000 divided by 1.17 raised to the 1. And let's do this calculation. It is 5128 approximately. Okay. 5128, okay. If you don't want to use this formula, this is what you can do in your financial calculator, okay? So you can do PV 6,000 I by Y 17, right? N equal 1, or actually, sorry, but it should be FB actually. CPT PV. Okay, so again, you're trying to find the present value of the $6,000 over 1 year at 17%. So similarly, if you want to find that 2922, which is the present value of the $4,000, we can do this. All right, again, so it's cash flow. This is cash flow 1 or C01, and the C02 is going to be this 4,000 divided by 1.17 square, or we could do future value equal 4,000 and equal 2, and I by Y equals 17, and compute present value again, and it's going to give you 2922. And you know, as you proceed down the timeline, year 3, year 4, year 5, all you have to do is change your N to 3, 4, 5, 6, 7, depending on how many cash flows are given to you. So again, the rules are all the same, but now you're doing something that's a little bit more accurate, which is again discounting the cash flows, and you should be discounting the cash flows. Okay. So once we have that discounted cash flow column, do the same again. We have that cumulative column, add that 8050, add that 9933. Remember, our initial cost was 10,000. So when we reach 9923, we subtract that. We have 77 left. All right. So we take 77. All right, 77 balance remaining divided by the next cash flow, which is 1067, and we get 3.07 as our discounted payback period. Okay. So again, depending on whether our what is it called, the cutoff period is 4 or not, or 3.5 or not, we're going to say yes, or if it's less than 3.07, we're going to say no. So pretty simple, again, very very simple in Excel, but even with your financial calculator or otherwise, it's not a very hard thing to do. So I'll give you one small assignment right now, so you can do, well, let's do the NPV payback period as well as discounted payback period of a set of numbers or set of cash flows. Okay. So let's do that so that we're more or less comfortable with the payback period method and the NPV method. So So we have the third technique we're going to be looking at is known as the IRR technique. You might have heard of it as well, but it's the internal rate of return. It's called the internal rate of return criteria. Okay. So rather than doing a cost-benefit analysis like we do in the case of the NPV criteria, or is the cost more than the present value of the future expected cash flows, or is the cost less than the present value of the future expected cash flows, NPV greater than 0, yes, NPV less than 0, no, or positive and negative, yes and no. What this IRR criteria does is to look at, what sort of return would this project generate over its lifetime. So that's again the internal rate of return criteria. Look at the rate of return rather than looking at just cash flows. Look at the rate of return from this investment, all right, so the project or product, and then compare it to the rate of return of other competing investments or projects or products, okay? So let's look at the IRR rule. It says decision rule, accept the project if IRR is greater than the required rate of return, and reject it if the IRR is less than the required rate of return of another competing project, or accept the project if the IRR is greater than the opportunity cost of capital, or the rate of return if you invested somewhere else. So let's think about this. All right. So we have the IRR criteria, and we have what's known as the OCC. So let's say you're evaluating several projects. You have your project, which is project A, and then you have alternative investments out there. Okay. So how do we apply the IRR criteria or IRR technique? How do we do that? So let's say we have again our project A. This is the project we're thinking about, whether we should launch it or not. And the return from this project, all right, or the IRR from the project is, let's say, 12%. We have other competing alternatives, let's call them OCC, all right. We have another investment or another project. Let's say the OCC or the rate of return we would earn if we invested somewhere else was 9%. Now we would say, well, the rate of return in our project A is greater than what we would earn if we invested somewhere else. We should go with project A. Let's say we had another project, call it project B, and our expected rate of return from project B is 20%. And of course, we're going to choose project B because, again, the rate of return or expected rate of return from project B is higher than the rate of return from project A. But essentially, what you're going to be given is, you have to calculate the IRR of the project. It's very, very simple to do. Compare it with the OCC, whatever the OCC may be, right? Again, an alternative investment or alternative project, or again, the rate of return that you are giving up by investing in this project, or the rate of return that you would earn if you invested somewhere else. Okay, so what you're doing is, again, comparing the return from your project, expected return again, the return you would earn somewhere else. If your return from the project is greater, you would say, of course, yes, because I would rather have higher return than lower. If it is lower, then you would say no, because I would rather invest my money somewhere else or invest in some other project than this one, because the rate of return is lower. And of course, our aim would be always to get a higher return than a lower return. Okay? So how do the IRR examples look like? It's pretty straightforward and very, very simple, actually. Let's look at them. So in case of the IRR, again, you'll be given a bunch of cash flows, and you will be given the cost of the project, of course, because you would need an initial outlay. And the question would look like this. What is the internal rate of return, or the rate of return the project would generate? Should you accept the project if the discount rate or the opportunity cost of capital is 10%? Okay, so if you're wondering where this came from, again, the formula over here is the total present value of future cash flows divided by the initial investment. So if you look at this, so we have the NPV over here. So let's say we have this and we want to calculate the profitability index. We would find the present value of all these cash flows and then divide by the $10,000. Okay, so the present value of all these cash flows, put it in the calculator without the CF0, and then divided by whatever the CF0 is. Not as commonly used as the other three criteria, but the book talks about it as well. So the decision rule is accept if PI is greater than 1 and reject if not. let's now look at, I have survey data. It's from, I guess, 2000 something. I don't remember which year this paper is from, but what do managers use in real life to evaluate projects? Okay, so we have Canada, North America here, Canada and US. And over here you see in parentheses the criteria that they use the most and the criteria that they don't use too much. We have NPV, used by Canadian companies, ranked as number 1. IRR number 2. 3 is payback. 4 is discounted payback period. Okay. For the US, we have number 1 as IRR, number 2 NPV, and 3 and 4 payback and discounted payback period. If you look at Asia, Australasia, again, we still have NPV, IRR, payback period, but profitability index is not that popular, as you can see. But again, this is based on survey data. So these surveys were based on, well, they send these surveys and they ask CEOs or other managers, well, what technique do you use when you evaluate projects? And then they made these papers based on the survey response. The managers usually said, well, NPV, IRR, and payback period are the 3 most commonly used techniques that we use normally, again, to evaluate projects.